This video is going to go over our 12.3 homework problems where we are finding the area of a trapezoid. So the first thing we want to remember is the formula for finding the area of a trapezoid. So it has base A, it has base B or base 1 and base 2. I'm going to call them A and B, so it's a little shorter. So we've got A and B, and we want to put those together to make a parallelogram. And that's the first thing that we're going to do. And so we want to put parentheses around that. So the next step is multiply, and multiplication trumps addition. So in order to do addition first, we're going to put that multiplication or the parentheses around that. So we add our bases and then times by the right angle height. And then we cut that whole thing in half. So this is the formula that we are going to be using today to identify the area of these trapezoids. So take the formula, plug in the information that you know, and solve. So step 1 is add, step 2 is times by the height, step 3, divide by 2. So we made a parallelogram. We want to cut it back in half to that trapezoid. So number 1 tells us that the Shanghai World Financial Center is one of the tallest buildings in the world. It features a large trapezoidal opening to allow the wind to pass through. Very interesting. So the opening is 35 meters tall. So the height is 35. So that's what we're going to multiply by. It is about 40 meters long on the bottom. So the first base is 40. And it won't matter which base you write first because they're just both added. So we can flip those around with the commutative property. And it's 50 meters on the top. So it's larger on the top than the bottom. Again, it won't matter what order we write those. So what is the approximate area of the openings? Want to remember, we want to cut that in half. Otherwise, we found 2 of these, we would have found a shape like that. So when we're done, we cut it back in half. So step 1 is we're going to add. Step 2, times the sum by 35. Step 2, divide, and that will tell us our answer in meters squared. Okay, number 2, I'm going to pop that formula up here for us. So a trapezoid's longer base is 3 times the length of the shorter base. So we've got the shorter one, we've got the longer one. This one is 3 times this shorter one here. The trapezoid has a total area of 32 square feet. So this is the area. So this equals the area. So we know the area is 32. We know we don't know these yet. We just know that the second one, the longer one, is 3 times bigger than this one. The height is 4 feet. And again, we'll always cut it in half. So we want to find the length of the bases. So we're looking for A and B. So we're going to be working backwards here. So the first thing that we need to do, so normally the last thing we would do is divide by 2. So we're going to do the opposite of that, and we're going to multiply by 2 on both sides. So go ahead and do that and then come back to see our next step. So this cancels out. And then here we have 64. We bring everything else down, equals A plus B times by 4. So the next thing we would normally do is multiply by the height. So we do the opposite of that. So the opposite of timesing by 4 is to divide by 4 on both sides. So divide by 4. So go ahead and do that and then come back for our next step. So 4 divided by 4 cancels out to 1. And then 64 divided by 4 ends up being got 24. So 4 into 24 is 16. So here we've got 16 equals A plus B. So we know when we add A and B together, they've got to equal 16. And A or B, won't matter which one of them has to be 3 times bigger than the other number. So let's think of some things that can add up to 16. So I know that 1 plus 15 can. So go ahead and see if you can list. So 4, 5, 6, 7, 8. Go ahead and put all of the partners together of things that add up to 16 and then come back. So let me finish writing my plus signs here. So 2 plus 14, 13, 12, 11, 10, 9, and 8. So our A and B have to be one of these pairs. So let's just start here with 1 and 15. We need to take this first one and we need to multiply it by 3 to equal the second one. 1 times 3 is not 15. So it's not this first one. So it could be any of these, but it specifically told us that the longer base has to be 3 times bigger than the shorter one. So 2 times 3 is 6, not 14. So go through and find the one that when you multiply by 3 equals the other one, and that will be your bases for A and B. Hey, number 3 tells us that one base of a trapezoid is 4 inches long and the other is 6. So we've got one that's 4, one that's 6. I always just like to draw them. It just helps me visualize what I'm looking at. And then it told me the total area is 25 square inches. So inches squared. So do the measurements describe a unique trapezoid? So this question, if you remember, we did one like this with the triangle. So it's asking, is there another way that I could draw this trapezoid, or does it have to look like this? Or could it maybe look like this or something like that? Or the other way. So is there only one way to draw this, or can I draw many different ways? So as long as the base and the bases are 4 and 6, and as long as this right angle height is the same, it's not going to matter what my trapezoid looks like. I could turn it different ways. So I'm going to say no, it's not a unique trapezoid. There's more than one way we can draw that with those same measurements. So we're saying it's not those. So now we've got to decide how far apart do these bases need to be in order to make this answer correct. So let's get our formula here. So here's our formula. We know that base A is 4 and we know B is 6. We don't know the height, and then we're going to divide by 2, and that all equals 25. So let's go ahead and work backwards here. So normally we would add the bases times the height. So we would normally add the bases times the height and then divide by 2. We already have the answer, so we want to work backwards. So the opposite of divide by 2 is to multiply by 2. So go ahead and do that and then come back. So these cancel out, and here we have 50 equals 4 plus 6 times the height. So this is what we're trying to get by itself. So we don't want to move that to the other side. Otherwise, then we just have to move the 50. So let's just keep it right here. So we need to get the 4 and the 6 to the other side. So we could move the 4 and then we could move the 6, or we can put them together and just move it one time. So 4 plus 6 is 10 H's. And we've got 50 over here. So we want to divide by 10 on both sides, and that will tell us the height. So 50 divided by 10 is 5 equals, this canceled out, 5 equals h. So as long as the two bases that are 4 inches and 6 inches are 5 inches apart, then it doesn't matter what angle they go at as long as they are 5 inches apart. So we just want to do everything opposite and backwards to get that variable all by itself. Okay, so then these next several are going to be much easier for us. They're pretty straightforward. They just tell us what the measurements are, we plug them in and solve. So go ahead and see if you can write out the formula for this trapezoid using these measurements. So A is 5.7 and B is 11.4. So when we add these up, we will want to remember to line up our decimals. So we've got these decimals here. So line those up, bring the decimals straight down. And our height from the right angle is 8. And then we're going to cut that in half. So go ahead and add 5.7 and 11.4. Multiply by 8. Don't forget to move your decimal. And then divide by 2. Make sure your decimal goes straight up. That will tell you that answer in centimeters squared. Okay, number 5 tells us, I'm actually going to move me over here so we can see our formula here. So a trapezoid has an area that's 18 feet. So we know the total area is 18. And the height is 3. So we're going to put height here, 3. What is the sum of the lengths of the bases? So it doesn't want to know what A and B are separately. It wants to know what is A and B when we add those together. So we're going to divide by 2. So we're just looking for this as one answer here. So first we need to do the opposite and times by 2 on both sides. Let's go ahead and do that. So there we have 36 equals A plus B. And this is the answer we want all together. And then times 3. So the opposite of times by 3 is, so we're going to do divide by 3 on both sides. So when I do 36 divided by 3, that's going to tell me the sum of these together. When we add A and B, it will tell me that, which is what the answer wants here, is A and B added together as that sum of the bases. Oh, I think this is number 6 here. Whoops. Okay, number 6. So this is pretty straightforward, pretty easy numbers here. So plug in A, plug in B, times it by the height. So add those together to get your parallelogram. Base, times it by the height, and then cut it in half to find our feet squared for this trapezoid. Okay, real number 7. So same thing here. Use A plus B, times that by the height, and then cut it in half to get back to our trapezoid. So make sure that we're putting these as meters squared to get the answer fully correct. So yes, we can just put the number, but that's not the best way to write that. We want to put that label on there to show people that it is what we're doing. This is finding how many square meters can fit inside this box here. Hey, number 8, take our first base, add it to our second base, times that by the height, cut it in half. So this one, I think as we're doing this, it's going to end in an odd number. So whatever this number is here, I don't know how many, I think I will have just 2 digits here. So we'll take that. It's an odd number. When we divide that by 2, it is not going to have this decimal. It will not go in there evenly. So we want to add this decimal and add a 0, and then it will perfectly go in there. So if it's a nice even number, it's just going to end. If it's not an even number, add a decimal, add a 0, or if it already has a decimal, just add another 0, and that will get the decimal to end nicely for us. Okay, number 9, using our formula. So this one is just flipped. So remember, the bases are always going to be the parallel sides. So if I'm looking at these ones, I can see my height goes here. The height connects the parallel sides. So we've seen a lot that go, the height goes up and down. This one's just going across. It's just been flipped on its side. So here's base 1, add it to base 2. Then, so remember, when we add, our decimals need to be lined up. We're going to multiply that by the height. Don't forget to move your decimals over, and then divide that by 2. If you need to add another 0 at the end of your number, make sure to do that. Okay, number 10 here asks us which trapezoid with these dimensions is going to have the largest area. So I know if I want the biggest area, that means I probably need the biggest numbers here. So we've got 6 and 9 and 5. So we're going to add our bases times by the height. And I don't even really need to cut it in half for this one, because whichever one has the biggest to start is going to be the biggest even after we cut it in half. So I can see that 6 plus 9, we need to add our bases. 6 plus 9 is 15, and I would times that by 5 to see what that equals. So then we can add our bases, times it by the height. So I can see this one is 10 times 8. So I already know this one is pretty easy, right? I'll help you out with that one since it's easy. Is 80. So we're going to add and times, see which of these would have the largest area. When I cut them in half, it's all going to still be the biggest one, still going to be the biggest one because it had the biggest area to start with as a parallelogram. Okay, number 11, the sum. So remember, that means when we add the bases, is 64. So it already took A and B and it already added them together for us. So it's saving us a step. So it's telling us that A plus B is 6.4. The height is 4. And then we want to cut it in half to equal the area. So it just already did one of the steps for us. How nice. Number 12 tells us that a trapezoid has an area of 36. So sounds like a working backwards one. So the total area is 36 square feet. The height is 8. One of the bases is 4. It won't matter which one you plug it in for. And we still need to divide by 2 to get it back to a trapezoid. What is the length of the other base? So first we want to, let's think of our steps. So first we add the bases, then we times by the height, then we cut it in half. So we want to do everything backwards now. So the first thing we'll do is the opposite of divide by 2. We want to multiply by 2 on both sides. So go ahead and do that and then come back. So this cancels out, and here is 12, 6, 72. And that equals 4 plus b times the height. Okay, so the next step, the opposite of timesing by the height, is to divide by the height. So we're going to divide by 8 on both sides. So go ahead and do that. So this cancels out. We're left with 9 equals 4 plus b. So we want to get b all by itself. So how can I get b all by itself? So we want to minus by 4 on both sides to get rid of that 4. So both sides. So 9 minus 4 will tell us the answer of the other base. Number 13, which of the following statements about a trapezoid with a height of 3 inches and an area of 54 square inches are true? So we know that, so we're looking for A and B here. We know the height is 3. When we cut it in half, it equals 54. So let's see which is true. So pretty much we just need to go through each of these and see which ones are true. So I will help you with the first one, and then I'm going to let you try the other ones here. So notice it says select all that are true. So there's going to be more than one answer here that we need to find. So one base is 36. The other is 1. So 36 plus 1 is 37. And then I'm going to times that by the height. So we've got 21, 9, 10, 11. So 111. And we've got to cut that in half. So this goes in here 5 times, which is 10. And 1 left over, it goes in there 11, 5 times. So already I can see it goes in there 55, and it's going to have another half left over. So it is not this one here. So go through each of these and try those out. So add the bases. So it's telling us the bases. Add the bases together, times it by the height of 3, cut it in half to see how many of these equal 54. Number 14 tells us that this expression is shown here. What is the value in simplest form? So I can't easily do 3 divided by 9 and 8 divided by 16. I could do it the other way, but that's not what the problem asked us to do. We can't just move things around when we're dividing. That gives us a different thing. So this is what we have to start with. This is how many groups we're cutting it into. So I can do the opposite of divide, which is to multiply by the reciprocal. So I can copy the first one, dot, and then flop the second one. And then that problem is much easier to do. I notice I can simplify 3 and 9. So what goes into 3 and 9 and cancel those out. What goes into 8 and 16 and cancel those out. That's going to be a lot easier to do that first, to work with smaller numbers. Then we're going to multiply across, and simplify if needed. Okay, and the last one I'm going to help you with today says Sue downloaded 20 songs for $25. What is the cost of one song? So we've got songs and we've got money. So 20 songs was $25. I want to know how much money one song was. So 25 times 1 is 25, and then we'll divide by 20. So 25, I'm going to add decimals there because it's money. And I know 20 can't go into 25 evenly, so we'll need some money, some change left over. So see how many times 20 goes into $25. Don't forget your decimal. And then I'm going to let you do number 16 on your own. It's just a subtraction problem, so you should be just fine with that. Hey, if you have any other questions on your homework, please let me know and we can set up a time to meet together.